Welcome to the third section of the course. In the previous section, we created an authentication service. In this one, we will create a web API that will use the one in the previous section to only allow owners of plans and subscriptions to read them and modify them. We will begin by writing the models. Since we are building a subscription as a service kind of application, we are going to need two models, a plan model and a subscription model. Subscriptions will be connected to plans in a way that each subscription will be part of a specific pricing. In our solution, we are going to add a completely new project. We're doing this because we want to separate the concerns. We want to keep our solution clean and we want our authentication service to be isolated. So I'm going to select ASP.NET Core Web Application from the dialog and I'm going to call it API. This warning, the name being too long, will eventually disappear, and I'm going to click on Create. It's going to take some time. It's going to load the libraries. Now, from all those options, we are going to go with API. No authentication, of course, and you can disable HTTPS, and this is just for learning. No reason. Go and enable HTTPS. And there you have it. The project is almost ready. You can dismiss this down. And it looks very familiar. We have a controllers folder, but we don't have a models folder. Let's go ahead first and install the dependencies. And since we are a database-driven application, we need an ORM to communicate. I'm going to use the same as in the previous video. I'm going to the SQL Server plugin in Entity Framework Core. Feel free to use any other database you may feel suits your needs more. You don't have to use the same database as the authentication service. You definitely don't need both of them to be SQL Server. They could even be a NoSQL database like most. So Entity Framework Core has been installed. Don't forget that we also need some extra libraries that help us communicate with Entity Framework Core and migrations using both the command line and the PowerShell tool for installing dependencies. There you go, installing that too. Let's remove the SQL Server part and search for tools. That's the last one. Again, click on accept on those dialogs. The dependency has been installed, but we're not done yet. We have more dependencies to fetch. This one is for the identity provider. Remember, in the previous section, our authentication service generated self-contained JSON web tokens. Those self-contained JSON web tokens can then be used with this library, this part of the authentication process, that our API doesn't need to communicate with the identity service. Those projects will never have to communicate either by sharing libraries or resources or even by making HTTP requests or any other form of communication. Next library that we want to install is the JWT bearer. The reason why it's not visible in the results is because I've used a space between the words. If we omit the space, this is the one with the purple .NET logo. It's the official library, part of the authentication library. Now you may be asking, why do we need the authentication library since we've already gotten an authentication/identity service in the previous section? Well, the reason is exactly what I was talking about a few seconds ago. The reason is that the web token is self-contained. It doesn't need a round trip to the authentication service in order to identify a specific user. We need all the information that we need in order to authenticate the user and authorize them to perform a certain action lies inside the token. But in order to read, parse the token, and confirm its validity, we need those libraries. That's why we're installing. We have them all. Let's go ahead and create a new. Remember, we need two models, the subscription and the plan model. So let's begin with the plan. So this is nothing more than a plain C# class that we are going to assign some fields. We have the primary key, which is required, and the framework will register it as the primary key simply because it's called out. Had we used another name, we would have to perform some extra logic to make it a primary key, but this is an entity framework core convention. Then we have the name. Every plan has a price. Remember, this is a pricing plan. Subscriptions will be created based on this blueprint. And then we have something like type for whether this is a monthly plan or a yearly plan. You could use the enum type for this, but since most of the time such applications need to scale massively various different types of plans, a string will also be fine. And notice that this user ID doesn't point to a real model. If you've used Entity Framework Core before, you may be used creating an association at this point. We don't, because the user model lies on another project. And remember, those two projects do not onto the subscription model that, if you remember correctly, does need to be connected to the plan model. Both of these are in the same project. We will associate them with a at the end of this class. Get the mandatory fields out of the way. We have the required ID, then we have the plan. So by doing this, we are essentially saying Entity Framework Core there is some type of relationship between the two, and we can even classify this as a one-to-many relationship by using the plan. And then we can add filler fields, like the coupon, a card number, because every subscription needs a card number in order to complete payment. Then later, generally all the information that a credit card requires in order to complete a payment. Notice that we don't need to do anything else to signal to Entity Framework that there's a relationship between the subscription model and the plan. Every other field is just a filler for us right now. The important thing that we connect each subscription to a plan, and a plan may of course be applied to multiple subscriptions. That's why they say one-to-many relation. Again, we are going with Entity Framework Core conventions. Most of the time I'm gonna go with, and the subscription also use a user ID, but note that again we are not referencing a real model. There is no user model in this application, so this user ID is not going to be a foreign key. It's not going to be associated with anything. Virtually it will point to a valid user stored in the identity database, but it will not very clean. We sacrifice this cleanness, this database normalization, for a more scalable setup. Now, we haven't fully configured Entity Framework. We need to create an app.db context. This is very similar to the previous video. Now, you should be very used to doing. Not in the previous section, in the authentication section, we used an identity DB context as the base class. Well, now we don't use this particular application as an authentication service, and we don't have a user model. Therefore, we're gonna go with typical DB context instead of the one provided by the identity path. We will set up two database sets, one for storing the plans and one for storing the subscription. These words will also be used as the table's names. So we're gonna end up having a plans table and a subscriptions table. And now let's override the onConfiguring method to provide the connection string. There are two ways of doing it. The first way is what I'm doing right now. I'm overriding this method and providing the connection string right then and there. The second method is to register it in the startup class, whatever you think fits your needs best. They're both perfect solutions. You can avoid your replication with both, You can abstract out the connection string to a configuration or environmental variable in both. So it's a win-win situation. It depends on your personal preference. So with hard coding the connection string for now, since we're not going to be deploying this application somewhere. So it's the local database. It's a Microsoft SQL Server, of course, and the database name, I'm gonna go with something SaaS, as in subscription as a service. And we could also